we present Animatomy, a novel, anatomical, animator-centric representation of the human face. The proposed system utilizes a collection of muscle fiber curves as an anatomic basis, whose contraction and relaxation provide a fine-grained parameterization of human facial expression. On top of this representation, we build a complete facial system to use in film production that produces high-quality facial deformation through the contractile strain of 178 muscle curves. We build Animatomy from 6 to 8,000 actor-specific and high-quality facial scans using a combination of machine learning and optimization techniques. The dataset consists of about 80 motion clips, where 60% cover face expressions and 40% deal with speech motions. A passive, quasi-static simulation is then performed to define a tetrahedralized volume between the skin and the bones. We extract dynamic muscle curves using the barycentric coordinates of each tetrahedron. We utilize muscle curves as the central representation of the system. We first optimize kinematic deformation from joint transformations of the jaw and eyes. System unknowns at this stage include weight maps for linear blend skinning and corrective deformation components to capture accurate kinematic movements that include rotations. After optimizing the skin deformation with muscle features extracted from the muscle curves, we have a complete facial model. At this point, the model also has an autoencoder trained to learn an expression manifold. Note that the overall reconstruction error is less than 1 mm for most parts. We have a muscle feature refinement stage to increase the deformation fidelity during the optimization process. The system iteratively refines muscle features by alternating system unknowns between skin deformation and muscle features. Animatomy can handle actor-to-character transfer in a systematic way. To maximize the parity between an actor and character face, we first align the character dataset to match the actor's dataset in the correct order. We then apply a radial basis function on every corresponding frame to transfer the actor's vertex displacements on top of the character's neutral face. We can refine transfer quality by introducing a small number of guide shapes to the transfer process. With guide shapes, a facial modeler can control the level of details or subtle nuances of the character's face, which are usually required when the actor closes or opens their jaw or eyes. Animatomy is designed to support various production needs from different artist groups. This result shows performance-driven animation solved with about 300 facial markers, and then the animation is transferred from an actor to the target character. For facial motion editing and keyframing, we provide animators with multiple ways to interact with the Animatomy facial model. A strain-based pose library is a collection of face expressions, and each pose is represented as a set of associated muscle features. An animator can use curated pose libraries to keyframe any desired pose, or fine-tune the current expression intuitively. We also provide a brush tool to manipulate skin meshes directly. When an animator brushes a local facial skin area, a per-frame basis inverse optimization is applied to find the best muscle parameters to the user input. Note that editing the actor's face is transferred to the character on the fly in real time. Here is a comparison of the Animatomy facial model with the face model created using about 200 blend shapes. Each model solves facial animation for the input marker sequence that has been synthetically generated from one of the unseen ground truth datasets. Both models generally follow the ground truth expression, but the face model fails to capture fine details. The same issue can happen when it comes to animation transfer, and the error can be significant if the proportion of the character is substantially different from the actor. Thank you for watching.